Scalars and vectors. Scalars and vectors are both mathematical quantities, however they have different properties. A scalar is described entirely by a magnitude. A vector, on the other hand, is described not only by a magnitude, but also a direction. For example, let this arrow represent a speed of 5 meters per second. No matter how this arrow is oriented in space, it still represents the same speed. However, if the arrow were to represent a velocity of 5 meters per second to the right, the velocity is only correctly described when the arrow points towards the right. As soon as the arrow points in a new direction, the arrow describes a new velocity. This is because the velocity is described by both a magnitude and a direction. Speed and velocity are one example of a scalar-vector pair that describe nearly the same thing. They both are measurements of how fast something is traveling. The only difference is that velocity includes a direction. Another common scalar-vector pair that go hand in hand with velocity and speed is distance and displacement. They both describe how far an object has traveled. Distance and speed are related by the equation speed equals distance over time. Displacement and velocity are related by a similar equation velocity equals displacement over time. The right side of these equations looks identical, even though they represent two different values. To avoid confusion, vector notation is used over variables to indicate that a variable is indeed a vector. To see the difference between scalars and vectors in a more practical approach, imagine a person travels in a rectangular path at a constant speed of 5 meters per second and ends up back where they started after 30 seconds. Following the equation mentioned earlier, we know that distance equals speed multiplied by time. Subbing in our values, we end up with the equation 5 meters per second times 30 seconds equals 150 meters. This means the person traveled a distance of 150 meters. However, if we look at displacement instead of distance, we end up with a very different result. When considering a vector, we need to find how far an object has traveled in a single direction with respect to the starting point. The person ends up exactly where they started. This means they were displaced a total of 0 meters. Here's another example that illustrates the importance of differentiating between scalars and vectors. Imagine you are preparing to drive from your house at point A to your cottage at point B. Based on your GPS, you know they are 240 kilometers apart, and the speed limit is a constant 80 kilometers per hour. Using these numbers, you predict the entire trip will take you 3 hours. Unfortunately, after arriving at your destination, you find that your trip took significantly longer than you had originally expected. This is because the road to your cottage is a very windy road. The 240 kilometers between them represents the displacement, and the 80 kilometers per hour represents the speed. Time can only be found using displacement and velocity, or distance and speed. Because the road is not straight, the distance is significantly larger than the displacement. This means the actual time it took to reach your destination is actually significantly larger than predicted. In conclusion, both scalars and vectors are mathematical quantities that contain a magnitude. Vectors, however, also contain a direction. Though similar, the two are not interchangeable, so it is extremely important to be able to identify and differentiate between the two for the sake of calculation.